Hello, welcome to the video. Um, in this video, we'll be looking at section 4.3, where we're going to be um, looking at rotations. For the most part, we'll be looking at rotations with respect to coordinate planes, but there are some examples where we won't, and again, we'll show you what that is going to look like. So it says, how can you rotate a figure in a coordinate plane? So what we need to look at is we need to have a series. We have some information that we need in order to make a rotation. So the first thing we're going to look at is you need to have a center of rotation. All right, center of rotation. And more often than not, especially in these examples, our center of rotation will be at the origin of a graph, so 0, comma 0. So that'll be kind of nice. And then we'll have some kind of rules to kind of go by when it comes to um, certain angles. And I'll kind of get into those in a few slides from now. But what we are trying to do is we're still, again, when it comes to rotation, you are still uh, keeping the integrity of the shape. The shape doesn't change. You're just rotating it off of that specific point. So what we're going to do here, it says they want us to draw a 120-degree rotation of triangle ABC about point P. So here is what you're going to do. The first thing you're going to do when it comes to a rotation like this where there's no coordinate plane is you're going to start by picking a point of one of the three, excuse me, one of the three vertices. So I'm going to choose A. So what I'm going to do is I'm going to use my straight edge and go make a line segment from, and actually I'll just kind of extend it so I can show you why I'm extending. So I'm just extending it all the way a little bit more because what we're going to do is we are get my protractor out. So looking at my protractor, I'm going to kind of rotate it over here and get, and I'm going to try to attempt to find 120 degrees. All right, so I put my protractor here, and now what I'm going to do is I'm going to find 120 degrees. So there's 90. So 120, I would say, is right about there. All right, so now what we are going to do is I'm going to just kind of move my protractor out of the way, and I am going to make another line segment. I'll use red because I use red here, and I'm going to go from here to here. So right now that is, so from the blue line to the red line is 120 degrees. So now, how are we going to get um, A prime, so the new point? So what we need to keep in mind is the distance from A to P needs to be the same distance to whatever A prime to B prime. So in order to construct this correctly, what you're going to do is you're going to take your compass and, whoops, delete that. So what you're going to do is you're going to take your compass, you're going to put the sharp end at point P, and then what you're going to do is you're going to take your pencil and you're going to extend it to point A. And then you're just going to come on over here and strike a mark. Where that mark is, where that mark is the location of A prime. So go over here. I'm just going to now. So now that's where A prime is located. So now we did that with one of them. Now we got to do with the rest of them. So I'm going to go. So I'll just go blue. I'll look at C, but I'll just extend it. And then move my compass out of the way for the time being. Bring my protractor over. Move this over here. Find myself 120 degrees, which is right there. Move this off to the side. And now I'm going to take my straight edge, which is red. And then I go over here. So now to find point C, again, take my compass, put it at point P, move it over here, attempt to get it close, and then I'm going to strike my mark here, and this is my location of C prime. And then the last thing is let's look at B. So go here, extend my compass, or extend my line just so it helps with my protractor. So kind of move this out of the way, go over here, move this, line this up best I can. There you go. And now I get to find 120 degrees, which is right there. Kind of done with this one for right now, so I'll just get that out of the way so we're not cluttering up my drawing. So now here is 120 degrees from that. That looks pretty good. And then finally, I'll take my compass, again, sharpen at point P. We're going to extend, oops, we're going to extend this to point B. Let's try to move this just a little bit over. That looks pretty good. And now I'll strike my mark here, and then this is where B prime is located. So to connect all the lines, I'll do it in red. So actually, I'll do it in a different color. I'll go black so it's more apparent. So A prime to C prime, C prime to B prime, and then B prime to A prime. So, and to kind of give you an idea what it looks like, I'm just gonna delete these little marks here so you can kind of get an idea. Lost the whole triangle. So this is A prime, B prime, C prime with a 120-degree rotation. So that's how you would draw it. If you have a coordinate plane and you are going to be asked to rotate it either as a 90-degree, 180-degree, or 270-degree, it's basically like you're looking at it like a translation because you're just, or a reflection because you're just moving some pieces around or making it the opposite value. And as long as you rotate it counterclockwise, these will hold true. So for the first one, it says if you rotate it at 90 degrees, what you're going to do is if whatever X and Y are, say they're A and B, what happens is you flip around X and Y and then you make it the opposite of B. If it's 180, you keep X and Y the same, but you just make them the opposite value. And then finally, if it's 270, you flip the X and Y value that you are given, but then you give the opposite of whatever the value of A is. So, looking at some examples like that, here it says we're going to graph quadrilateral RSTU with vertices 3, 1, 5, 1, 5, -3, and 2, -1. And it says they're rotating the image after 270-degree rotation from the origin. So what we're going to do is I'm just going to look at the coordinates. So it's going to be R prime, S prime, T prime, and finally U prime. So we're going to get our coordinates from there. And if you recall, it said that if you have coordinates A, B at 270, what you are going to do is you'll flip A and B, but whatever A is going to be the opposite. So if R was 3, 1, that means R prime is going to be 1, comma, -3. If S was 5, 1, this is going to be 1, comma, -5. If T is 5, -3, then it's -3, comma, -5. And then finally, U prime is going to be -1, comma, -2. In this particular situation, we have two things that we're going to be looking at. One, we get the translations like we did in 4.1, and then it says that we are doing a 90-degree rotation. So we're going to have, for the first part here, we're going to have A prime and B prime, and A prime and B prime are just going to be taken care of. Looks like it'll be subtracting both of our x and y coordinates. So -4 minus 2 is -6 for A prime for the x coordinate, and 4 minus 1, which is 3. So -6, comma 3 is our A prime, or yeah, our A prime. And then we can say that B is going to look like, what is it, -1 minus 2, which is -3, comma, 7 minus 1, which is 6. So that's A prime and B prime for this particular um, situation. And then it says they want us to rotate about the origin 90 degrees. So remember when you had 90 degrees, it was A comma B, and then with 90 degrees, you flipped it, but it was the opposite of whatever the value of B is. So let's look at A double prime and B double prime. So A's are going to remain the same, but they're going to be in the Y value. So -6 will stay, and -3 is going to stay. The change will come from 3, it's going to be opposite. It's going to be -3, and then 6 over here will be -6. So when something is translated the way it's translated and rotated at 90 degrees, those are the coordinates we'll be looking at with respect to the original line segment. And then the final thing we're going to take a look at is looking at rotational symmetry. So a figure in a plane has rotational symmetry when the figure can be mapped onto itself by a rotation of 180 degrees or less, about about the center of the figure. This point is called the center of symmetry. All right. Note that uh, not every figure has rotational symmetry. Each figure does, in fact, has the possibility of having a center of symmetry and not having rotational symmetry. So, for example, if we were to look at um, this parallelogram, so let's say if I'm trying to find my center here, it's gonna, let's say if I'll make it blue. So if I say I made a here and I went here, for instance. So where these two intersect would be my rotational symmetry, or not my rotation, my center of symmetry. So in this particular instance, what I could do is if I actually rotated this exactly 180 degrees, it would look like the original image. All right. I don't know if this is yeah, so let's see if I can do it. So if I just rotated it 180 degrees, you know, let's see if I can, something like so, I'm able to get the same image as I rotated it. If I look at um, like this one here, if I go from here to here, and then like say something like here to here, and even maybe it's not quite in the middle, so something close like there. So you could say that that is my center of symmetry, but it seems like if you could rotate it, in a bunch of ways, like so even like a small rotation like so. So like 45 degrees, or even now 90 degrees, or even 135, or the full 180. You could tell that you could make, it still creates the same image from the original image. Now, the trapezoid, trying to create the center symmetry would be somewhere right about here. And the trouble with this is there's no um, way I could create the same figure by rotating it. So you'd have to go back to the original one. So the trapezoid, this particular trapezoid in this case, does not have any rotational symmetry. And that is looking at rotations. I hope this helps. Until next time.